In this application, we'll be using the rational rule to help Narita decide how many workers to hire for her restaurant and how many meals to serve in her restaurant. Right, so in this table, we have a lot of data here to try to capture Narita's revenue and costs of producing different meals and hiring a number of different workers. In that first column, we have the number of workers she could hire. She could hire 2, 3, 4. And those number of workers will be used to produce meals. And so if you hire 2 workers, you can sell 160 meals, 3 workers, 210 meals, 4 workers, 250 meals, and so on. Now you're going to sell those meals, and you can sell those number of meals at $25 a pop. And so we can get our total benefits. And in this context of a profit maximizing restaurant, the benefit side is going to be the revenue you get from selling these meals. So we'll take $25, the price of a meal, to sell it, and times the number of meals, 160. So we'll get these numbers here in terms of then these will be our total benefits. We can also construct our total costs for Narita. So these are going to be a more complicated formula. She's got to do $10 per meal in food costs, $300 to pay the waiters' wages, $500 in rent, and then $1,000 for Narita's time in terms of the opportunity cost. And so we have this column here. Now, applying the rational rule, we want to compare marginal benefit to marginal cost. And so we need to calculate the marginal benefit column here, and we need to calculate the marginal cost, right? And then we can compare the two. So first, let's start with our marginal benefit. To calculate a marginal benefit from a table like this, we want to difference 2 rows. So moving from the second worker to the third worker, what is our additional revenue that we get from hiring that worker? And so that would be $5,250 minus the $4,000 in row 2. And hiring that third worker is going to increase our total revenue by $1,250. We can get marginal benefit for that fourth worker, the movement from that third row to the fourth row in that total benefit column. And so that would be $6,250 minus the $5,250 for a marginal revenue of $1,000. And so we can move down these 2 columns down across these rows, differencing each additional row from the previous one to get the marginal benefit of hiring an additional worker. So these numbers are specific to that additional worker, okay? And that's going to be important. All right, so now we have our marginal benefit column. Next, let's do marginal cost. Same idea. We're going to be differencing the total cost column. How do the costs change when we hire 1 additional worker? And so we'll be taking 4,500 minus 3,700 to find the marginal cost of that hiring that third worker. And so that would be $800. We find the marginal cost of the fourth worker by differencing those 2 rows to get $700. And so on down that column to fill in. Great. Now we know how to calculate our marginal benefit and marginal cost. We can now do the comparison of applying the rational rule, comparing marginal benefits to marginal costs to decide how much or how many workers that Narita should hire. All right, so we'll compare this 1,250 to the 800, and in that case, for that third worker, marginal benefit is greater than marginal cost. Yes, we should hire that third worker. Compare marginal benefit to marginal cost again. 1,000 is greater than 700. Hire that worker. Fifth worker, marginal benefit's greater than marginal cost. Hire that worker. Sixth worker, they're equal. That means we stop at that sixth worker. If we go on any more, then we have our marginal costs are greater than our marginal benefits. So you can think of this, the costs are going to go up more when you hire that 7th worker than the revenue you get. And so that's going to make your profits go down, and that's bad. So we don't want to hire that 7th worker when the marginal costs outweigh the marginal benefits. Okay. So that's the rational rule. It says hire 6 workers. That's going to maximize your profits. In this case, our profits are the economic surplus of this profit maximizing firm, Narita, in her restaurant. So to convince you that we're actually maximizing our profit, I'm going to take the total benefit column minus the total cost column, and you can say this is profits or our economic surplus. And so for the second worker, Narita would get $300 in profit. Third worker, $750, $1,050, $1,200, $1,200 again, and 1,050. Okay, so the way that I calculate those, I would take the total benefit column minus the total cost column, and we get the profit she would make. Right? And so as we go through here, our total profit's going up, up, up as we hire more workers. Here it's staying the same, and then it starts going down. So the maximum is going to be this sixth worker here. And again, you might think, why are we hiring that sixth worker when it's not really adding anything to profits? We have marginal benefits equal to marginal costs. Why would we do that? I just want to remind you again that this is to make our life easier. And so whenever you set something equal to each other, it's easy to find with math. It's easy to find on a graph. An equality like this, it just means we can find two lines that cross each other. So in my class here, we're always going to consume, or we're always going to hire, and in this case, the object where the marginal benefit equals the marginal cost.